Namaste and welcome everyone. Welcome to the session 5 of the bootcamp. And we have two more sessions left next week, Monday and Wednesday. So we'll continue today with the object-oriented programming and look at some other topics and then discuss exercise 3 towards the end. So I hope that most of you have attempted the vending machine problem, and uh, thanks to those who have shared their solutions so far. And I have placed a link to people's solutions here actually. And as we get more solutions, I'll keep on updating it. Note that I have not really verified these solutions, but these are solutions that could help you to see give a picture of how the problem should be solved. Uh, it may be working, it may not be working, and that's for you to check. Okay, and at times we are going to pick some of these solutions and I'm going to look at it. And today I'm going to look at one of those solutions while discussing object-oriented programming. Okay, so the videos are all being uploaded on YouTube right afterwards. I hope those people who are not attending live are making good use of these videos. Yes, and before we begin, anything you want to say or you want more to be discussed, please put that in the chat. Welcome to those who've just joined. Right, okay, so I'll just open. So the last in the last class, we were discussing introduction to object-oriented programming. We discussed these palindromin examples, and then we also went over the vending machine, but we did not complete the vending machine. There are a number of things left there, but that is all for you to try on your own and to compare with the solutions. Okay, so the introduction to classes, we went over this class called robot, and so how we can declare a robot class in two different ways, where one we have not we are not passing any parameters to the constructor, whereas in the other one we are passing parameters to the constructor, but both of them do the same thing actually. And then we went over this class called square, and then we looked at how we can initialize the square class and how we can place some functions in the square class and do some computations in the square class. I hope this all makes sense to most of you. If any part in here, any line here is still a bit confusing or something like that, just please put that in the chat. I will go over it again. Okay, so anything so I assume all is good, so we can then continue with the others. So let me move into week 5. So in week 5, which is today, sorry, session 5, could be seen as a week as well. So we go into this OOP folder. Let's see what we've got there. And there are some other examples of object-oriented programming. Let's see what they are. Okay. That ends session 4, and now we're in session 5. Session 5, and we can open this class person. So similar to a class robot, you could have a class person, and the person class would make more sense to you because I can give more examples very easy. So there's a class person, and this is in your main. basically that person class is being called. So let's type person, right? So we have class person is, we are directly calling the p.name, and Ranjita, my sister's, my elder sister's name is Ranjita, but she's not 23, since I am very sure she cannot be my elder sister, of course. Yes, so the class is here, and it has two variable names there, right? And we can always add more variable names, like self dot weight equals 0, and a person's weight will never be 0. We know that. Okay, let's just put another variable just for the sake of it. Note that this variable name, it doesn't need to be always the same as what is in self.w. I mean, this would do work the same actually, but in here, from here, if you do a print w, for example, is weight, just assume age for my sister, she's in Fiji, and I don't know, okay, I'll be a bit kind to her, and a bit kind to myself. No, that's just exact. So I'm just putting these two weights there, right? So okay, so you see that we have W is not defined, right? We placed these weights there. These weights were entered there, and they entered here. The weight has been now updated to self.weight. And but why I am trying to print weight from another function here, right? And essentially this cannot work, because within this function, W is not defined, and that's quite clear. This W is an unknown W. It's not the same W that is there, because the function will execute based on the things that are defined within the function and based on things that the function gets. It's not getting W. And note, when a function gets nothing or a method gets nothing in a class, you have to place self there, basically. That kind of makes it part of the class, right? And so what we need to do, we need to do this basically, and then that should be what. Okay, so you can see that the names are there. I mean, you could always have you could always have a first name and last name as different uh, variables, and then you can place first name and last name. Okay, so let's try to do that. Let's separate the names so that we can get the first name and the last name. Okay, I give you a few minutes to try that. Let's change this a little bit so that we can see first name and last name entered, and then you enter your details. Add another call to the class by placing your details. Okay. So, you can see both P and R, and I want you to find yours so that you something. So let's do this now. Okay. Yes. Okay. Let me just update. So you can pull it you can pull person.py and then define yours there, right? That's the first thing you can do. And then once that is done, then you should separate the first name and the last name. Okay, anybody wants to put the definition, their definition in the chat? Let's see what it looks like. You don't have to be entirely correct about your age and weight, okay? So that's how you introduce yourself to the class. Place call to this so person. So basically, the same class is being used. It's just that the variable. So the class is person, but the reference to it here is Ranjita Kumari is P and Rohitash Chandra is R. So we want another one to be added where your information is going to. So thanks, Michael Horton. Michael, uh, I meant the whole Python code, like this whole thing, not just the information that you give. What would it be? So let's just use Michael's information here. So let's call that M. So okay, great. Thanks, Michael. So that's a good age and weight. Okay, so now we got Michael here, and now we need to see if those things are defined. Okay, so you can see that Michael is defined. So we are kind of building a database, right? Now let's say that we want to have we want to separate the first name and the last name. So can you do it? Let's say F name, L name. So that's kind of F name and last name, first name and last name. I just call this F name, first name, and then let's quickly do this. So this is how database management systems are built. They are using classes. That's how your Facebook, Twitter, and all these accounts are done. You know, they are all using classes. Okay, so you have age, and then we know that first name, and then the print function should be having last name. Okay, so let's do this. And then all of these should be now, because we are giving it first name and last name. And note that at the moment, it doesn't matter if your names are in capitals or small. It's just taking it as a string, right? So any others, any other volunteers? You wanna put your details there so we can quickly add to this machine before we print this out? Anybody? Okay, so nobody wants to give the details. Okay, so we will put a detail of a guy. Okay, that's great. Thanks, brother Manu. Um, and it's uh, it's great that I think Abhimanyu is the probably the only person from US attending this, I would assume. Long way, and we have interest from different parts of the world. And thanks, Hillary. And Hillary has tried that, and that looks great. Yes, and right. So great. So I'll just put some more parts there. So let's try to put more functions there. Hey, can you think of any function that we can add to this class? You know, something cool. Anybody, any ideas? You wanna put it in the chat? Any function that we can add to the class? Printing ascending age. Yeah, so if we want to do that, if you want to print this by ascending age, so you are like sorting things or searching for things, right? So what is the problem here? Actually, thanks, Michael. And okay, we can add things like email, right? That's very easy for us, right? Self dot email ID or something, right? Is equal to email. That's quite easy, right? So people can just put their email, and we can put something in the email. Okay, something like that. So we replace email ID. So we can add more and more things in this class. But if we want to do that, what Michael just mentioned, that is going to be a bit complicated. So that basically we need to make this as a list. Okay, so we need to do that as a list. We need to define the class as a list. Okay, and that's not impossible. That's doable. So let's do that. Let's do that. A list of persons. So there are several ways you can do this. You can append the persons to a list. Yeah. So you could also add height and then do a calculate BMI and all those things. So right after this, we can do the BMI example. Okay. But just before this, let me show you how we can make a list of classes, and that's the most important thing I see, because that becomes very useful. And note that in here, basically, you could always have some other information, like list, uh, like for example, past weights. So somehow, let's say that you're making a program where people are trying to monitor their health, right? So every day they try to put in a new weight, right? So let's do this. So at the moment, the past weights, there's nothing in there. And then we have a separate function. So people are monitoring their health, and they can, I mean, uh, they can also enter height, but height doesn't change so much, especially for adults. So so past weights, right? So we want somehow that person to update the past weight, right? So I think we can just leave this past weights as the best thing would be we can leave it like this. So this basically becomes an empty list. Okay, this becomes an empty list, and you basically give the past weights, and as you give the past weights, let's say we should have another so the person basically also enters the date. Okay, this can become a bit little bit complicated because the date format may be in a string, but yeah, okay, we can still do it. We can still do it. You can just ask for month. We can ask the user to give that information. So what happens is whatever is that value, should be, so dot append will basically, so this is not using numpy, this is just using Python uh, lists. Okay, so okay, so that's it. So what do? We can just ask the user. So not everybody is interested to update their weight. So let's say, I mean, a lot of people are download these apps, right? A lot of people download these apps and they don't want to give all that info. A lot of people don't use the apps. They don't put the weight. So not everybody here is going to update their weight. Only some people may use it, right? So let's say that I'm interested. So let's say R. So we printed the information and R wants to update the weight, right? So if I say like this, so here you can decide if I just put a number. So I say, and the date I can just put whatever format that I like. Or we could ask the users that you should always enter in that format. Okay, where for example, what is the date today? So let's say I entered this weight on. We could always make the months different, right? But let's say this is the format we are using for the date. So this is where I update my weight on that day, and I update my weight on this day, gain a bit of weight And then I update my weight again, let's say after I get my COVID shot, and it's because maybe I walked all the way to the place to get it, and so I'll gain and lose a bit, right? And these are things there. So let's say that when we are printing, we should just at the same time, print the password. So and, and we say weight history, and we can, or we could always have a separate print function as well. Okay? Right. So now, got upset. Don't make Python upset. Okay. Note that Python is a snake. If you make the snake upset, you can be in trouble. Okay, so we have some issues. Okay, the issues are here. You cannot put when you're calling, you cannot do that, right? And then basically, I do that, and then I want to see what shown first, and then I print, do a print call again. Okay, right. So all the things are being printed, and what is happening is there's some problem definitely. Past weight is not defined, it's saying. Oh, okay, see. See, even very experienced programmers will keep on getting errors, okay? So errors are part of life. Don't take them as a form of, as something that demotivates you. You keep on improving your programming, Let's say Z is not defined. I don't know where Z is. Okay. Was revenue, I called that variable that, and now, okay, so we see the names, and then again it, so in the beginning it's printing, but everybody has 0 in their weight history. But now I printed my part, and then it's now giving that information. Okay, I just put the first name and last name so that it looks neater. So this is basically object-oriented programming for you. I don't know why the first name and the last name is the same. Why? Because the last name was not going in the last name. And okay, so now you can see my weight history is there, and you can have your height history and many other things part of this. Okay, so this is one way. So let me just push this so you can pull and check as well. Just a sec. I'm just trying to look for the code in my other computer where we can define a list, a list of persons. Okay, so we can just copy this, and in OOP, let's make another program for list of persons. Yeah, so it's here. And what we want to do, so all that is there, that is fine. But we want these, I mean, let's say we entered this, or this could be always read from a file, okay, in a for loop, if this information was in a file. That we don't really have the time to do now, because I actually wanted to look at this list of persons. Sorry, I'll just stop my share so I can quickly get that code that implements the list of persons. Okay, there are many ways to do this, and one way is you define your list upfront. Okay, so you define your list upfront where you have something. So we're not printing anything now. So this is like a way where you are defining your list upfront. So let's say the maximum size of your list will be 20, and then and and then basically you can define parts there. Basically, it could be, you could use a for loop to just initialize things in the list. For example, this, right? So we can use a for loop. Let's say the size. So, and we can just say from 0 to the size.
Sorry, Rohit, are you meaning to share the screen? Because we cannot see the screen.
Oh, okay, okay. Okay, thank you. So, yeah, sorry, sometimes I miss seeing the chat. So let me open the chat for you. Right. Chat is lost somewhere. Okay, I can see the chat now. Okay, so basically this is like this is a way to make this list. It's not the most efficient way, but it is a way, and I am using this way of my implementation in a problem. So in basically in here we are saying for that whole list which we made here of size 20, basically we are this basically means it's just making a memory blocks of size 20. Okay, and in each of those, as we are going, we need to pull the persons. So the person, and we need to give it some information. So let's say that in the beginning, just for creating the persons, we need to give it some basic information that will be always overwritten when persons are added. Okay, so we just say first and last as the names, you know. So what happens now? Let's just see. And to print the information, it will be like you can the first person, you know, list of the person that now you are going to access that all as a list. So print info, that will print the information about the first person. Okay. Python is upset again. Note that you can use, see when you go down there, there's always, if you click that and you copy everything, select everything, you have indentation to tabs and indentation to space. So everything is converted now to tabs. Okay, so you don't have to manually do it all the time. Okay. So now we did not print anything, but you can see first is the first name and last is the last name, and 0 is age, and there's nothing in the white history. Why? Because we have that created. Okay, so now we have a list of persons. Okay, so and we can always be doing things like, you know, this. So that's one way. That's one way of printing. Okay, that's one way of printing, and we want to print everything now, and you just access the dot person. So sorry. So that's how it is. Okay, so let's see what happens. So you see the whole list is being printed. Okay, so you can say that the print is there, and we can say print n. So that means we can see the that actually I think the we should always have an ID. Okay, so that's the person ID. Okay, it's kind of a person ID number. So let the, it's like we're developing a database and people, and in the beginning basically all the ID numbers are what is being entered there. Is as people come, the ID number is incremented or decremented. Okay, so in here, let's say the ID number, we would have to manually put things like that if we are using that same you know, otherwise it won't, it can be anything. Okay, so it won't run. But now we are, when we are printing now, we are not, these things are already defined, and they are separate things in memory. They are known as p, q, m, and z, right? And then this is basically in memory a list person of size 20. Okay, so these are separate things, and now you, all of them will be having that ID. But I printed that ID here, but I think it's better we print this thing in the list so we know what is the ID. Okay, so this is basically very useful because and actually your exercise 3, you supposed to develop a vending machine basically. That is, first use object-oriented programming, and then basically you assume that you have different vending machines in different cities. So you could make a city vending machine, like you have to define that vending machine as, you know, Sydney, Melbourne, Wollongong, something like that. So that's one thing. Another thing is like you can develop a list of vending machines like this. So now you can see is the ID. Okay. So and then yeah. So that's good. It's important. And then another way is you do things something like this. You know, that's one way of making a list. Another is just you define list person. This is another way, and then you just something like that. So and then you basically keep on appending to that list as you get see the information. So this will also make uh, I think would be this is another way. This should be another way. Let's see this prints again. So when you are now accessing, so the other way, in the other way, let's say we want to say first or last or something else. I I say it in Hindi. Pehla, aakhri means first and last. So let's learn a bit of Hindi, okay? Or the pehla and aakhri are not printed, so should be saying first name and last name, okay? So the list person is the append is having some problems. Let me see what is going on here. Am I printing the thing? List person, okay? So why? Okay, so why did it print for all of these when I did not really call the function that's printing it? Let's see. So you see, I have commented the print information here. I just have print information for one person, right? But it's still printing information for everybody. This is strange. Is it being printed from here? It would not be.
I think it might be you have list per, not list person.
Okay, great. Thanks. Great. Right. So this is how we make mistakes. Okay, but still it's printing. Okay, so it's printing. All right. So Pahela and Akhri, the first and the last names. That's great. So let's make the size a little bit smaller so it's easier to see what. Thanks for the comment. It saves us time. Yeah, it's easier if you mention it. I mean, I keep forgetting to check the chats. So see, and the oops. So let me probably push this so that you can also run it to see what's going on. So afterwards, then you can do things where you can sort, you can enter information of these persons, like these things can be entered. Okay, so let's say that that's done here. So what would that be? So so that then this function is kind of not a good way to enter information anymore. Why? Because it either you read this from a so because we already entered this information here, and we just need to update the person. So you know, when we create a new person, we want to update that information. So we need to have another function which is very similar to this, where all that information is being updated. Okay, so let's just quickly add a function, then I will then push it, meaning add person. Okay, so we created some sort of list, and in the add person, we can give the ID of the person. So let's say the user tells what the ID of the person is. Okay, and it gives all this information in the add person, so that whatever is that person from the beginning, it starts to be updated. So how do we do this? We need to add this person to the list. So we need all this information to be passed to the list. Right. So and then we need to manually basically tell where that person should be added. Both the top and the bottom lists are basically addressed, accessed similar way, where you, so we know 0, and note the way Twitter or Facebook is doing, they are using efficient databases to do this. So it's usually stored in some database, but this is an example of how these databases have been constructed. But of course, those are very sophisticated databases. 81. I got upset here. So it's saying R is not defined. 54. Okay, let's just take this thing out, and maybe we can do something to that later. So because we want the person, this person to have that weight updated. Okay, so we see now all of them is having, so the first group is the first name and last name, and that's there, and then there's, we are saying another way. Okay, and then so 0 is ID, and in the 0 ID, all these IDs are updated now, right? And then afterwards, basically nothing is shown. Why? Because we did not print the list. Okay, So now we print the list again. Okay, then we print the list again. And then we have all the names are now updated to the list, you know. So Ranjita Kumari, Rohitash Chandra, Michael Horton, Abhimanyu Sahu, and then the last one is Pahela and Akhri because that's what was there already. Okay, but note that in one of them, which is Rohitash Chandra, the white history and date history is there because this was added to that one, right? So these IDs are there, and then as an exercise later you can think of, we don't have the time right now, think of sorting the list by weight, let's say. That would be like you will have to use bubble sort, implement a list version of bubble sort, which will be quite a bit to think about, which could be a bit difficult, but you could try. The other would be searching name in the list, in the list. So okay, that we can try. Let me push this first. So push this. So now our list has been created, and we can, so you can pull the list and you can quickly run it now. And so there's a lot done, a lot to understand. Third person, we have update weight, those properties are in the list. We have a list of a class, and then we have a list of classes. Okay, so this is so far so good. And we want to do one more thing is we want to kind of search for somebody in that list. Okay, so the way we will do that is we'll use a for loop, because let's say because we are searching, our list is not sorted, so we'll have to, if the list is sorted by name, which we'll have to implement that sort function, and we've seen bubble sort, in session sort, and they're better sort functions. Basically, the place where you just access your list, you'll have to access list in this way, right? So in a different way, but we can see that how that works when we are doing a search, you know. If so let's say we want to enter a name that we want to search. So I just search for my name, right? So, and if in that list persons, right, then we can access the first name dot, if that list has f name is equal to name search, or right, if the first name, so when the something is entered, they, let's say users don't really tell whether it's the first or the last, so that's where you use this or, okay, or last name, then basically it will supposed to give the print information, and the ID of that person will come and all the details. Okay, so let's see. So that is, the list is printed, and then at the end it said the first name is one is the ID and this. Okay, I'll make it more user friendly. Okay, now let's, so that it's given there. and see one of the entries. Oh, sorry. So, and then now you can see, now let's search for the name, and 4 is the ID we found Abhimanyu. There's both the first name and the last name, right? So this kind of shows you how do you implement a search, and similar way you'll access that list to implement sort. Okay, and then that list becomes more comprehensive. So this is quite okay for a start. Let's try to quickly transform, see how we can develop another one, which is we want to develop a program for body mass index. Okay, let's say. So I'll just copy this, and now I'll just paste it here. Okay. New file. Okay, any comments, questions so far before we move to the on list person? Okay. So far so good. Okay, let's take a 3 minutes break, and then we will plan how we can do a body mass index version of things. Right, so we'll just transform that to a body mass index. Okay, let's continue. So now we have Kelvin's solution. I didn't really run it, but I can see some nice functions being written here. And basically, how do we transform this into a body mass index problem? So there's find age, find height, find weight, calculate BMI, right? So let's say that these things are already done. Let's just do a calculate BMI first, and then we can do the age and the other one. Calculate what class you have. So we'll just use the same function. We'll just append to this um, let's say we use the same function, and we can just put this there. So the calculate the BMI is there. All we need to do is basically put self, okay, and then the weight and the height it takes, and it calculates the BMI, prints, and returns. And then we have another function which is calculate, check what class you are, and something like this could be more of a global variable probably. So I'll just move that on top here. And basically we have self, and note that we need to add this part. Basically it could be that we want the person's BMI to be, everybody has a BMI, okay, so we can put it that as part of the self, okay. And let's say just when it's initialized to 0. So if you have the BMI, then you don't because the BMI now will be globally accessible, then you don't have to really return it, okay. So that should be fine, but you could always return it just for showing that you are returning something. And see, I have indented everything, and I'm just converting it to tabs. And so there's some groups. Don't know how this is done. If the age is something greater, then there's all these rules there. But now because the age is something which is part of the, so you don't really need to worry about it. You can just call it. So what is this self dot? The sum function is taking in, this is like a shortcut or using whatever the inbuilt function is doing. So the sum, it's summing if the BMI is greater than the adult classes. So looking at this, and in there it checks the whatever is the BMI. If it is greater, then it sums this. Maybe that is the part of the exercise, and it's just checking what group you belonging to, and giving all this, there are these different groups there, and this is probably what was given in the exercise. And then again we have another reference to self, and then that's been done there. So age, we say okay, self age is greater than 18, else that. So these functions are basically, so it will look something like this. So let's say that we want to compile this. So at the moment, line 106, we have a problem. Okay, so let's say that we are using the previous ways to, we add a person and we update the weight. So we're not dealing with the lists anymore. Okay, we do this without lists. We just trying to check. So we just don't do it. We just do a. Let's say you have all these people, and then so now we don't really need to worry about this update weight. So at the moment we just call this. Okay, so because it's saying I is not defined, why? Because I, so let's just say I is equal to person, right? So let's not worry about the person. B is equal to person. So we have two people, but we are interested about the BMI. Okay, so far so good. Let's say let's say that we want to call the calculate BMI. Is that calculate BMI should be calling this function. Okay. And basically this function, the weight and height, you don't really need to pass this anymore, because those are the things that are already part of yourself, right? So but you need to call this function when you are calling the, so you just need to call this function. Let's say you call it here, but note that within, when you are calling a function here, you all have to say self dot. So this is the way how you call a function within your class, and outside of your class you will call this function. Let's say I, you don't pass anything, calculate class, and then let's say that we want to Yeah, let's just run this, just see what it does. It says the person does not have any height and weight. Why? Because we had a weight, but we didn't really have a height. We're just putting this height as 0 just for now. So, okay, it doesn't like 0. We're just saying a height of 1 is, so this person's, this person is obese. Why? Because we are not actually, so when we created this, we automatically placed the weight and the age, okay? But now we need a way, we need to use some of Kelvin's function where it's asking age, height, weight, okay? These three things. So these three functions, age, height, and weight, basically we can just call this, we can just copy these functions and we can just paste it there. So there are a number of functions from the past, like update weight and others. They are not being used, but we just leave them as they are. So find age is there, find height is there, and find weight is there. And basically, we don't need them to retain this age, height, and weight. We could be just so asking the date of birth, and then it's calling the, you can call the find age again, else it just retains the age. So basically we already have an age, and what it would do, it would be age, rather than retaining the age here, it would be, we should say is equal to age. Okay, so the age is updated. Then the find height, okay, let's just, we can use these functions as they are. Okay, we can also just use them as they are. Show you, we can basically just update these within the we can use a similar format as he has done, so that it's looking similar to this. So we define this, and then we just do the age. So and let's say that we are giving the age, height, and weight right here, but that's not, that won't be a really efficient way. Yeah, let me, sorry. So let me just, when we are calculating this BMI, we should just do this here, let's say. So these functions will be called, well, these three functions will be called, your age, height, and weight will be updated, and that's the age, height, weight. Whatever was entered in the initially, that will be again updated. So because we don't want the age and the weight to be updated here. So we can just say, the age in the beginning is just 0, height is 1, and weight is also kind of 0. At least they are just not, there's nothing in there. Okay, so now we have the tab and the space issue. So we'll just try to move this to tabs. And it's saying that this because we are not giving these two informations anymore. We know the person's name, we are getting the person's, so this is more becoming like a website. Okay, so enter, please enter any key to start. Okay, so any key to start, and it says find age is not defined. Okay, see, this is it's good in a way. You can see which errors are there. So find age is not defined, and this find age is not defined. Why? Because when in here you are going to call all these functions, which these are within your class, so you'll have to say self. Okay, and all the other places where that find age is being called, you have to say self, right? And okay, so that's there. And any other place where the function is being called, no, no. So this is a combination of methods which so find age takes this. Okay, let me just push this much so you can also start fixing this as I'm fixing it. So yes, it's pushed. So you can start fixing this as I'm fixing. Just pull it and start working on it while I am working on it too. So it says line 99 in calculate class, find age takes 0, but 1 was given. With find age. Okay, so now you see, the self is not there. So all of them should have a self. Okay, so date of birth. It's getting complex here. So it's calculated my age correctly. Enter M for meters. Enter the height in meters in 2 decimal places. Enter weight. Okay. I say that I'm normal. Wow, I'll have such a nice day today. I thought I was slightly obese. A friend of mine told this. Okay. Maybe the classification system is not doing the right thing. Who knows? I just want to say one thing. This classification system does not really apply to all ethnic groups. Different racial ethnic groups, they have different healthy and obese range. For example, Pacific Islanders. You have in the Pacific, you have Melanesians, you have Polynesians. And they all have different body types, right? And Indians may or may not really link well to this. But this BMI was mostly devised for for Caucasians with mostly European and North American studies. So I wonder how accurate this is. But anyway, so the BMI is kind of working, and we don't have too much time, so I would just quickly commit this and ask any questions or comments that you have. So as an exercise, you can think of a list. Think of a list of BMI for different persons, something like that. So this is how program has been transformed to BMI. And now next in your sorry, that's me cheating by looking at my passcode. So I forgot the code to create a list of classes, so I was looking for it. I'll just say bootcamp. So you see the parts here. So the first part of your exercise 3 is number conversion. And I think yesterday or the day before we did spend some time on number conversion. And basically, as I said, you need to read up a little bit about ASCII. We saw the table of ASCII number conversion, and it has 0 to 9 and then all the way to 15, but A, B, C, D to Z is there. So like 9A refers to number 10, probably, if I'm not correct, wrong, something like that. So that's base 16. Okay, so this is 9 in base T 10, and 1FA is that in base 10. So the different bases, so the thing is like, so you have done for base 2 and base 8. We were looking at the example last time, the base 2. It's just you need to change the base in the algorithm, and you would be able to convert any digit to any base. Typically, there's base 10, which is decimal, base 2 is binary, and base 8 is octa, and base 16 is hexadecimal. These are the typical ones that's used in ASCII, but you could convert to any base. You can have base 3, base 4, base 5, base 6. The base basically means that that's the upper limit of the number. So base 2 means that whatever is your digits will be will be just 0 and 1. Base 3 would be your digits will be 0, 1, 2. Base 10 basically means your digits are from 0 to 9. Okay, that's what base 10 is. So there's have a go at this, read about it and think about it, and you can write it specific functions. And then we have a vending machine revamped. It's basically the same vending machine. All these things are there, but basically these things need to be implemented as functions or methods in a class. So you need to use object-oriented programming to do this. So whatever you did in your previous vending machine, if you couldn't do it, then just take the code that we did in the class. Your vending machine doesn't need to be fully complete. Just that much is okay. And try to convert it into a object-oriented programming version. And then finally, you think of a machine list. You could make lists such as vending machine, Sydney vending machine. You can declare different classes, right? One vending machine class for Sydney, one vending machine class for Melbourne, things like that. And you can play around with that. But we can also assume there's a nationwide vending machine, and then we want to see how that is being updated. So in reality, if there's these machines like this, because we have so much of automated things, these vending machines all around the country would be kind of accessing some software where they communicate with the internet, and they give their information to this server, right? And let's say that in the server, so you have a class vending machine, and then you have in the main, your main is your server, right? And there you have a list of vending machines with different IDs, let's say, and things are all being updated to this list, like, so from that list of vending machine, you can run operations where you can calculate what is the total after a day of, 10 vending machines. What is the profit made? What is the, you know, how many items need to be restocked? All those summary statistics. You could do that from the list of vending machines. Basically. That's the general idea. So you can be creative. You can be as creative as possible. The thing is that you need to kind of test our programming skills, and programming is all creativity. Is art. Okay, it's art. You do learn it slowly. It takes a while to learn. You have to be very patient, and it's very similar to how you do painting, you do pencil sketching, you do oil painting, and yes, so painting is a hobby of mine, but I haven't painted much. But I always see programming as a form of art. Yeah. So that's one thing, and this is like in the future when you have time, you want to come back to it, then you can think of a web server version. You can think of a graphical user interface. So with Python, you can create graphical user interface so that you see a vending machine, like GUI, graphical user interface of the vending machine, and then things are entered, and then basically that's how things work. Okay. So, okay, so now we are going to go on to the next stage, the next lesson. So we have covered most of these things. One thing we did not cover was inheritance, and then we'll cover the final thing, which will be simulated anyway. Okay. So inheritance is like when you have two classes, and the thing is like inheritance is similar to what do we do, what do we have in real life. You have property, and basically that property is usually inherited by children. So you inherit property of your ancestors, right? Your ancestors worked hard, your parents worked hard, they have a house, and then they have, let's say, 3 children, and then they can inherit the property. So uh, that motivation is used in object-oriented programming. So you can see classes where you can use specific members or functions of the other class, and that's what inheritance is. So as an example, we go back to this OOP folder, okay, and we go to what is this? Inheritance. Okay, so inheritance. Okay, Python inheritance. Let's compile this. Or interpret, this is the right word. This is, my name is Jerry. Okay, so we have a class. We have seen this class already, and then we have another class. We have seen a similar class like this. So Robert has name, color, weight, and a person has name, personality, and another feature that says this person is sitting. Some more features there, right? Robert does not have personality, but this person class has personality, right? So, and introduce self is there, and sit down is there. So we have this class Robert. We have R1 and R2, right? So these two declarations are there, and then we have a class person. Similar things are there, and these people, please keep away from Alice and Becky. They are too aggressive. And so is sitting is just a true or a false, and if somebody is standing and aggressive, that's even worse. So the thing is, we have how is inheritance used here. So we have P1 robot owned is equal to R2 and R1. So we are just declaring two other variables, and basically we are just assigning things from here to these two other variables. And basically we have robot owned, which is P1, person one is owned this robot. So basically means we kind of think that the person class owns a robot. This person owns a robot, right? And then what is the name of that robot? So we can see that is dot introduce self is being called here. Okay. So the person robot owned is being introduced. So that's just a class of inheritance. I think this example is not that great. So let's see if we have another example. But it's just basically that you're supposed to, when you are inheriting something, you're supposed to that from this class, you can access members of this class. That's basically idea of inheritance. And that's what's being actually done here from this class. Let's say this person one, like person one. Let's say if we can access dot introduce self. So at the moment, the person object has no attribute because the person should be able to address all of these things, but the person has no right on these. That's what it is saying. Okay. So if you enable inheritance, basically this person will have rights on these things. Okay. So let's see if we have the example to show this. So we have right. So we have another example. We have a person, just a class person. There's nothing in there, and there's a class employee. That is the employee. When you pass the person in the employee, that is supposed to inherit the properties of the person. And then there's another person, manager, and the manager is inheriting properties of employee, and entrepreneur is inheriting those other properties. So that's how inheritance is implemented. So at the moment, in order to do this, let's say that what if we place this person Robert there? So it's now so now you can see this is the example of person inheriting elements from Robert. See, before we didn't do this, we had an error, but now we can see that we do not have an error. So what is happening here is this is the actual inheritance example. Okay, so what is happening is what was in person one? What was Alice, right? And it can inherit things from the Robert class, and okay, so let's say we just we don't want to do anything there. And it says my name is Alice. So it just inherited the name Alice, and essentially Alice was the person, but it can be using functions from this to print. Okay, so what it actually means inheritance is this thing basically is being copied. This function is, you can imagine it as being copied as one of the functions there. Okay, so that's what inheritance is doing. So why did it not print Robert, Tom, or Jerry when it says introduce self? Because uh, P1 P1 does not, has nothing to do with Tom and Jerry. They are different class objects altogether. They are different pointers altogether. P1 just knows about person Alice, but P1 did not have any function that was actually printing or introducing uh, the person's identity. That function is only in the robot, but now we can use that function basically here. Okay, so inheritance is basically a smart way. We can say that there are many classes and you can inherit functions of other classes. Okay, and in that way basically you have modular programming where you're efficiently solving problems, and inheritance is all around the place. Every day you are using your social media and all other things. A lot of uh, features or in there are using inheritance actually. So you could have, for example, you could have a class person, right? And then you could have a class. Okay, so in a university system, for example, in a university system, you have a class person, right? You have a class person, and in a university system, you could have a class student, and you could have a class academic, right? So academic and student, these two classes will inherit the features of person because both are academic and a student is a person. Okay, so you could always first define a person class, put the names and things there, but in the academic class you are going to have some other things like the class student will have GPA, and academics don't need to have GPA, but the academics can have in their self, the academic will have salary. Let's say salary. Students don't get salary, right? So you have a list of academics, you have a list of students, and students list have GPAs, academics have salaries, and they are all inheriting features from the class person. Okay, so we'll see if we have some time next week to go over this example of inheritance again of what I just mentioned. Okay, so we have some other things to be covered, and actually basically what we have already covered, object-oriented programming, classes, lists, and inheritance. This much is quite useful for you getting by, and you will be able to read about all these things, and there are more videos on YouTube about inheritance and things like that. So all the lessons that I'm teaching, some of them are very introductory, some are advanced, and you should use this information from the boot camp with information from other classes in YouTube or other other university classes, and basically these boot camp complements those things as well. So okay, finally we now go back to a basic algorithm. So far in the previous class we have discussed integration, right? Integration is basically you are looking for the area in a function, right? And we have another critical topic in artificial intelligence and machine learning and applied mathematics and mathematics as a whole. A major topic is optimization. Optimization and optimization is essentially trying to look for the best solution in a given problem. Okay, so the problem can be defined as a function, right? A function, a very simple example of a function or an objective function is x squared. Y is equal to x squared. So that's x. Okay, or another way to write is y is equal to x to the power 2, or uh, or what is written here, right? So that's a very basic function. Okay? So this is basically taking the function list and giving some value to it, right? So let's say that we want to call this function here. So that's a function, right? And we want to find what is the minimum in that function. So if we say objective, print objective, so we are giving it the value of x is 3, and what would be the print statement? That's the value of y, right? Let's say because because this function is taking a list, so it needs to be that way, I guess. Right. So what is the first thing? It said 9 is y. Okay, 9 is y. So this function takes a list. It's a list of only one element, right? And let's say that function, there's another function, similar function, which is called objective func. Okay, and that basically takes that does some so that's this is another function, and that does the same thing, but it does it for a multi-dimensional input. Okay, so that's that. So the first one was just, it can just do for one, and the other one is like the objective func is something that can do for many values. It could be 10 different values, but we're just showing for 2. Okay, so it could be different numbers, like randomly generated. Okay, so what should be the value? So it would be x squared plus x squared, basically. Okay, so that's what it is. plus equals. So that's another example of a function. X squared plus x squared. Anybody can tell me what the value would be? What is 3 squared plus 2 squared? Anyone? 3 squared plus 2 squared. Okay, 13. Let's see if Michael is correct. So 13, that's great. Thanks, Michael. So this function can take any such values. That's a function, right? And basically an optimization problem, let's say, is that you want an algorithm where for that function, what is the minimal values that it should have? What so um, uh, right? So what minimal value should it have? So that's the part that's an optimization problem. Okay, so minimal values means that what values of x would give you the lowest value of y. Okay, so what values of x would be giving you the lowest value of y? So like we could always do it so we could always in a for loop find what values would be giving, let's say if we did that just for 5 times, and we could pass it that. So you could see that saying y, the y, just hold on. So we'll come back to this later. So what we need is a set of values for x that will work. Actually, the reason this was not working is because I was not putting it in the right place. Right. So you can see if you give it 0, the value for y is 0. And as your x values are increasing, then so are your values there, So if you can plot this, it will be, see, from minus x, so it started -5, then your y is 25. And all the way we go to 16, because we'll go from -5 to 4, okay? So the minimal value of x is 0. Okay? And the same here, 0 should be the minimal, right? But that is actually not known by the computer. We need an algorithm that finds what that minimal value is, the minimal value of any function, right? So how is this thing being useful? So we see an algorithm that actually can report the minimal value is known as a simulated annealing. Basically, why an example of optimization is a traveling salesman problem. And the animation that you see here, a traveling salesman problem is that a person visits multiple cities in a country or in a state, and the constraint is that one city this salesman can visit only once, and what route to take so that the minimal distance is used and all the cities are covered, right? So we have all the cities here, and basically energy, you could think E as the route, the distance. So it starts from a very large distance, and over time with the algorithm, the distance becomes smaller and smaller. The route, it gets improved and improved, and so on. So this is an example of traveling salesman problem in place, and this is a 3D version of it. The E is the, let's say, the distance, and T is a temperature. So over time we start the simulated annealing is actually a method that's motivated by how the annealing process of metals, right? So in metallurgy, right? And if you have seen any of these places, these labs, or where they'll take, if they want to transform a metal into some shape, you need to basically heat the metal, and basically once it has higher temperature, then it's more easier to transform this metal. And then as the temperature becomes lower and lower, the metal becomes harder and harder, and then it's harder for you to transform the metal. So usually if you take a block and you want to transform it into a cube, metal cube, and you want to transform it into the shape of a ball, you would have to heat it up, and then quickly, when it is really red hot, you start your hammer and start shaping it up very fast. And as it becomes harder and harder, I mean, the temperature becomes lower and lower, it starts cooling, the metal will become harder and harder. So towards the end, you can only make small jumps. So that's the idea that's used in simulated annealing. Basically, you begin with a large temperature value, and you can visit many different routes in a city. You can experiment more, you do more global search, and then as the temperature becomes lower and lower, then you should more do more of a local search. That's what a simulated annealing is. So that is here is a temperature value, and let's assume that this was some function. This is some function, and this is basically that function could be, let's say, the distance of the city, and every red point here represents a route. So every route gives you a distance. So in the beginning, because the temperature is high, we're just exploring and looking at many different routes with many different distances. But over time, as the temperature becomes slower, then we are converging to a solution that we know that along these route would be the best solution. So that's what it's trying to demonstrate, right? So that's what a simulated annealing is. Algorithm basically does in the grand scheme of things. So the algorithm is simply a for loop, could be implemented as a while loop. Basically, you take a solution, and the solution can be cities, a route of cities, or the solution can be just a random number that's generated, such as for the value x, a random number. Rather than iterating, we just use a random number function. So let's say it generated, use the random number function. For example, we have random I hope I don't know if this works. So, and basically we feed these random numbers. So okay, great, yeah. So this was the random numbers, and that's the y values it gave. Okay, so in a in here, so let's say this is x is our random number, and then the random number is that, and then that's the objective of x. Okay, so that's just a way to show what's going here. So the x value, the random number that was there, it gave a y of this, right? So we can put many random numbers and it will give these y values. Okay, so that's what the start is. In the beginning, let's say we start with a random number, x, or random value of x, and it gives us a y value. Okay, so and then we kind of do this till our we pick up a temperature. So let's say we start with a temperature of 100, and then we pick up a neighbor, the neighborhood of a solution. So we started with this solution, such as our first solution here is x of 0.6 minus 0.6, right? And the thing is that the neighborhood is like you add a real random number. In the case of optimization, in this sense, you just add real random number. Like it could be like plus minus. You generate another random number, a small number, like between the range of 0.05 to minus 0.05, any random number, and then you add that random number to this. So what is that new value? That new value would be, what is the new value that you get? So that's the random neighbor, right? And then you basically accept or reject that as your new solution. So in this case, let's say we had this as the, sorry, we had this value as our random number, right? We started with this, and we started with this value, and this value basically gave us this value, right? Y. So it gave us this value. But then we made a neighbor. So neighbor is you generate a new number. That means we can add some noise to this number. So let's say the new number is, instead of that, it's 0.1, right? So it will be similar. The new number will be similar to the previous one, but you have added noise to that, right? So, and then you evaluate that, right? And how do we evaluate that? We'll have to call this function to evaluate that, of course. And let's just evaluate this, the same objective function. We just, so for the first time we evaluated this number, this was the value. The second time we evaluating that number, what is the value? Is, you can say, is y. These ones are just, that's the y. So that's the y star. What will be the new value? Okay. So we have two numbers now. We have the previous one, and here it says, actually this, so let's say that our x has changed. Okay, the x here is this, and then what would be the y? So first time around our x was, a random number, which was 0. And then basically we evaluate the x, then we evaluate the x, then we did something to the x. We added a very small random noise to the x, right? So that's the neighbor, and then we want to find what is that neighbor. Okay, so that value is the value of your y. So now we have, just go here. So we have a x of minus 0.60, and that gave the value of y. And then we have another x value, which is a new x value, which is a random noise has been added to that x, and that's the value of y, right? So now let's say that we have a place where we say, so then we basically either accept or reject this value of x. So this value of y's are used to kind of determine how good your proposals are, how good your values of x's are, right? So that's basically the optimization problem. So simulated annealing is basically implemented what that algorithm is there showing there, this thing basically start from a state of S0, which we just showed the X, and then you have some kind of a for loop. You decrement your temperature, pick a random neighbor, and then you either accept or reject the value of S, and then the final state of S is given. Okay, so that's simulated annealing, and then it takes the function, objective function. You can do for objective function there. This is the objective function, but you can also do it using this objective function, which is multidimensional, and that's the example of objective multidimensional objective function. Okay, sorry, I'm running out of time, but I'll just finish it in the next 5 minutes. So we generate an initial point, right? So we generate an initial point just like we generated the X. We manually so we generated it, and that random point needs to be between two bounds. So it should be like between a limit, like -5 to 5, right? So in here, the bounds is -5 to 5, right? So that's what is being called the bounds. So between that, we generate a value of X, and we call that best, right? And evaluate the initial point. So we call the and whatever that best value is, right, whatever we generated, we say best evaluated so far, right? So that's the Y, right? So this is exactly what's being done here. You generated X and you are evaluating X, and that's called your Y. That is your Y. That's your objective function. That's what your X is worth. Okay, and then you basically make both X and your best as your current and current evaluation. Okay, so best becomes current and current evaluation. Now you basically have you should give it a maximum number of iterations. And in the maximum number of iterations, you use a for loop, and basically you take a step. Basically you can add a random noise to the current. Basically, what was your current value? You add a random noise there, and that random noise, how big should be that random noise? That's what the step size is. So you can add bigger large number of noise or small number of noise. That depends on your step size, and this is user defined. Okay, so that's also passed to the function, and in this case our step size is 0.1, right? And basically we add some noise to the current. Then whatever was that candidate that you added noise to from the current, you evaluate that again. Okay, then you have candidate evaluated. Then you basically check if the value of the candidate that you just proposed, your neighbor or your new candidate, is that better than your best evaluated so far, which was your best was what you did in the first time. So whatever was your past, you like in here, you're comparing with your current, right? So whatever is your past, you comparing with your current. If it is the best, then you just print that. That means the new value that you propose, the neighbor, that is better than what was there in the past. In terms of the traveling salesman, the new route may be having a lower distance than the previous route, which will be having a higher distance. And the goal in traveling salesman is to reduce your distance traveled. And in here, basically, the goal is to reduce the value of Y that you get, the candidate, right? So this is just a very simple problem function, and this function can be replaced by a traveling salesman function in the future. And basically, if that is done, and then you calculate the difference between the candidate and the current, and then you have a temperature, you calculate temperature for current epoch. That's based on the temperature that you got, which was passed to your function from your main, and the value of temperature is 10, right? And that value basically of temperature, you are going to kind of slowly decrease that. And then you take the Metropolis Hastings criteria, you take -1 diff of temperature. So that's, you can think of it as a way where you are going to now either accept or reject the solution based on your temperature value. So if the solution is good, you are accepting it as the best solution. If it is not good, then you accept it based on a probability. And that probability is related to the temperature value that you have. So what happens is, in the beginning, you get to accept solutions that are not so good enough, and that's what it is called global search. But over time, as the number of iterations increase and the value of the temperature decreases, then you are not going to accept poor solutions. You are only going to accept good ones. And that's when you, in the area of the metals, you are converging and cooling down. So that's what basically the traveling, simulated annealing is, and it's done for this very simple function, which is x squared just for 1 day. I would like you to read about these, and we'll continue a bit on this again on Monday. And basically your exercise 3 is about extending this, exercise 3 part 3 is about extending this function, and write this as object-oriented programming, and basically try some other functions that are there. At the moment, it's done for one-dimensional problem, which is, as you can see, your x is just 1, but you can extend it to multiple dimension where those this x, and I have already stated what a multi-dimensional function is. So it could be in here the number of dimensions is 5. Okay, and this could be 10, for example, can be 20, for example. So that's a objective, multi-dimensional objective function. Basically, it looks in here this way. Are there other examples of multi-dimensional objective function? Yes, there are. And one example of that is Rosenbrock function. So in and what does ellipsoidal or a Rosenbrock function looks like? So this is an example of a Rosenbrock function here. Okay, so these are all your y values, and this is x1 and x2. This is two-dimensional Rosenbrock function. And the optimization problem is that you need to find what is the value of your x1 and x2, let's say, where you get the minimum, this blue area, right? So that's basically an optimization problem, right? And there's another function called the Rastrigin function. Some functions are quite smooth like this, and some are very rough, and that's the Rastrigin function. And you need to find what is your x1 and x2 at this point. This would be the lowest value of y that you get. So this is another example of optimization. So I should have shown these figures to you first. So this is what all is in the optimization literature, and you can implement the Rosenbrock, Rastrigin, and ellipsoidal function. Basically, you can Google about them, and there are Python implementations of them already. And you can make objective function Rosenbrock, objective function Rastrigin, objective function ellipsoid, and then for 10 and 20 dimensions, run this and report what values are you getting in terms of the y values and the corresponding x after the temperature becomes 0, for example. So I know this is a bit difficult to grasp, so that's why I thought I'll give a quick introduction first, let you think about the problem, and then we'll look about this at this problem again on Monday. And on Monday, we'll continue with the optimization a bit with gradient descent, and then we will move into linear regression, where we are using that gradient descent to kind of make sense of data and develop a small model that can predict some values, which is called a linear regression. And you'll be given exercise 4, and then on Wednesday, basically you will cover logistic regression and a very brief introduction to neural networks, how we can play with data and so on. The other thing that we'll do on Monday is we'll also learn how to read data, how to visualize or do some statistical operations on the data. Okay, so this is all for today. Sorry. Yes, Abhimanyu, what's your question? How you implement the expected values in code? What do you mean by expected values?
So, can I speak?
Yep, yes, please.
So I always work with deterministic systems. So if you go back to the simulated annealing, that condition comes as probability of that condition. What is that? The metropolis here.
Yes.
So that's the condition. And if you go back to the wiki page in the algorithm, it uses expected value. For if I look into the code, like that one, it says there is no expected. Oh, did I read something wrong?
So this expected value e here is actually in the code. In the code, the e. So expected value is also called NAG in simulated annealing, and that's basically what you get from the objective function. Like eval is your expected basically.
Yeah. So, but my question is like, this is a question from long standing. From I try to understand this. So whenever I run these iterations, I pick one value. Maybe I'm sampling from a distribution somewhere, but whenever I do these calculations, I use that same instant value, same random value to evaluate that. It is not the expected over all samples. No. So am I like making sense?
Okay, that's fine. I think we are running out of time. So what I will do,
we can talk offline.
Yes, and on Monday I will go over this again, and then you can then mention again, because Monday I will run it and then I will print all these expected value, the temperature values, and try to make sense of how it is actually accepting and rejecting new solutions. Okay.
Yeah, my algorithm wise, my question is okay. What I wanted to understand is if I move to a stochastic domain and all these things are written in expected values, and when I see the code, it seems like they are pretty deterministic.
Okay. Okay. Yeah. So sounds like a research direction maybe. Okay. Okay. Then I'll see you all Monday. Thank
Yes,
you.
yeah. Thank you.
Okay. Any other questions, comments? Okay. So thank you, everybody. I'll stop recording now. I'll see you on Monday.